So, for the longest time, we've taught our smartest AIs to be like high score chasers in a video game, just relentlessly pursuing rewards. But what if that's not the real path to intelligence? Today, we're going to look at a fascinating new approach that builds AI not on a hunger for points, but on a real thirst for knowledge. So, let's get into it. And this is really the central question, isn't it? I mean, think about it. If an agent's entire existence is just about maximizing a single number, can it ever be truly adaptable or creative? Is that real intelligence? Or is it just really, really good optimization? This question sets the stage for a pretty fundamental problem in AI research. And that problem? Yeah, we can call it the reward trap. And it's basically a side effect of the most dominant and, frankly, most successful method we have for training AI today. So that method is what we call reinforcement learning, or RL for short. And look, the idea behind it is actually brilliantly simple and super powerful. You give an AI a goal, you give it points or rewards when it gets closer to that goal, and you just let it figure out the best strategy to get the most points. This is behind everything from AIs that master Go to ones that are designing new drugs. So, a good way to think about these systems is as reward chasers. Their entire motivation, their whole reason for being is just to rack up that score. Literally, every single action it takes is weighed against one simple question. Is this going to get me more points? Okay, and this is where the trap actually springs. What happens when the path to that reward isn't obvious at all? What if the goal is so far away that the AI gets zero feedback, no points, for anything it does at the start? It's kind of like being lost in a huge desert with no signposts pointing to the oasis. A classic example of this is the mountain car challenge. You've got this underpowered car that needs to get to a flag at the top of a really steep hill. Now, the only way to do it is to first drive away from the flag, up the opposite hill, just to build enough momentum. A reward chaser AI gets completely stuck here. It figures out, okay, moving a little bit toward the flag gets me 0 points. And moving away from it, well, that's definitely not going to work. So what does it do? It just rocks back and forth in the valley, totally trapped, never solving the problem, because that reward is just too far away. Right, so that's the problem, and this is where a completely different approach comes into play. Instead of building a reward chaser, what if we built something more like a curious scientist? So this new way of thinking is called active inference. And the core idea here, it's a total paradigm shift. I mean, really, instead of chasing external points, the agent is driven to confirm its own internal map of how the world works. Basically, its main driver is to just reduce its own confusion. It wants to understand its environment as accurately as it possibly can. And this, right here, just lays out the difference perfectly. The RL agent's world is all about those external points. But the active inference agent, its world is defined by its own internal beliefs. It's the difference between doing something because you're promised a cookie versus doing something to figure out how the whole dang cookie jar actually works. And you can see how this leads to a totally different internal monologue for the AI. The reward chaser is always just thinking, how can I get more points? But the curious scientist has this more sophisticated two-part question. It's asking, okay, what can I do right now that will teach me the most about this place and also nudge me closer to where I want to go? See? Curiosity isn't just a side quest, it's baked right in. Okay, so that sounds great in theory, right? But how do you actually build an AI that can balance these two things? Curiosity and goals? Well, the answer lies in a single, pretty elegant mathematical objective. The secret sauce, according to this research, is an objective called the free energy of the expected future. Now I know, that sounds super intimidating, but stick with me, because the concept behind it is actually beautiful. It's one equation that elegantly merges that drive to explore with the drive to achieve. Okay, so here's the magic of it. By trying to minimize this free energy, the agent is forced to do two things at the exact same time. First, it has to maximize what we call information gain. That's the curiosity part. It will pick actions that it thinks will teach it something new. And second, it has to maximize extrinsic value, which is just a fancy way of saying go after your goals. It's one objective that naturally balances exploring the world with exploiting what you already know. All right, enough theory. How does this curious scientist actually perform when the rubber hits the road? And the result is it's astounding. That mountain car problem, the one where the old AI gets stuck forever, the curious scientist solves it on its very first try. One single trial. And you can see that right here on this chart.
The bar on the left, that's our curious scientist agent. It just nails it, maximum returns almost instantly. And why? Because it wasn't obsessed with a reward it couldn't even see. Its first job was to figure out the physics of the world. So it rocked back and forth to learn, it figured out the whole momentum thing, and boom, puzzle solved. Meanwhile, the other agents, as you can see, are just stuck down there in that reward trap, barely getting off the ground.
Okay, but that leads to an even more interesting question. What happens if you take the goals away completely? If there are no points to chase, what does a pure reward chaser do? Well, pretty much nothing. But a curious scientist? What does it do?
Well, they ran an experiment. They put an ant agent in a maze with absolutely zero rewards. And the results? They speak for themselves. An agent just moving around randomly? Yeah, it barely covers any ground. But our curious scientist, driven only by that desire to understand, to reduce its uncertainty, it just systematically explores a huge chunk of the maze. The curiosity alone is enough to create this really complex, intelligent-looking behavior. So let's pull back for a second. What does all this really mean for the future of AI? Well, it's a huge sign that maybe we need to think beyond just chasing rewards. Look, this approach is a really big deal for a few reasons. First, it helps us escape that classic dilemma of when to explore and when to go for the goal. This AI's core mission is to do both at once. It also lets us set goals that are way more flexible than just a single number. And you can see it's a massive step toward more adaptable general-purpose AI. And maybe most importantly, it shows that pure curiosity can be a primary engine for intelligence. And that, it leaves us with this one last, really fascinating thought. If you build an AI that is fundamentally driven by curiosity, what's it going to choose to learn next? What parts of our world or our data is it going to decide are the most interesting puzzles to solve? And honestly, the answers to that, they might just surprise all of us.